Okay, folks, test 4, number 9. This is the classic example of where picking real values or using the values given to you is the key. So, they tell us a equals 2, so we can just plug that in to begin with. And the picking real values approach means literally just put these values in. It's either 2, 3, or 6. There's a high likelihood it's 3 or 6 because that shows up multiple times, whereas 2 only shows up once. So, I don't know, try out 3. If x equals 3, let's say 3 minus 2, does that equal 3 minus 4? So no, it doesn't, because that's the square root of 1, which is only equal to positive 1, not negative 1. So that means that 3 does not work. And we only have 2 options left. It's either 6 or 2. You would maybe try out 6 because it shows up in multiple answers, but honestly it doesn't matter, because if 2 doesn't work, it has to be 6. If 2 does work, then it can't be 6 just based on our options here. So I'll try out 6. If we have a 6 minus 2, so I'm just putting 6 in where x goes. So this is the square root of 4, and does that equal 2? Indeed it does. So 6 is the right answer. That's the picking real values approach, and it's the shortest distance to the right answer. The normal approach would be, put this 2 in and then do some algebra. But there's a trap lurking for you. So if you have this, that's just putting the 2 in, and then you square both sides, which is what you would do to get rid of that radical, you'd have x minus 2, and just to be safe, I'll write x, my best practice is to write x minus 4 in parentheses twice so I can actually FOIL it out and make sure I don't make a silly mistake. That's x squared. 2 groups of negative 4x is negative 8x. That's, this and this. And then the last would be positive 16. Negative 4 times negative 4. Then for quadratics, move everything over. So subtract the x from both sides means we have 9x. Add the 2 to both sides means we have 18. And then folks will factor it. They'll get x. We need 2 negative signs in order to get a positive 18 and a negative 9. And we're going to use, a 6 and a 3, right? And then it appears as if we have x equals, 6 here. Oops, let me not write it that way. It appears like x equals 6 in order to get this to be 0, 6 minus 6, or x equals 3. And we would think it's both answers. But, of course, if you do it this way, you have to go back and check for domain issues. Now, what does that mean? That means this radical sign messes everything up. You can't just square it. You can, but you have to go back and check to make sure that there's no issues where that is, a radical, the square root of 4 is only 2. It's not negative 2. The square root of 25 is not negative 5. It's just positive 5. That's confusing because negative 5 squared is 25. But the square root of 25 is only positive. So you would have to go back at this point and plug them in. Well, why do all that when you literally had those answers to begin with? All that work we did only got us back to the place where we really started this question, which is they gave us values 3 and 6 and just an additional value of 2 to try out. So if we're going to have to try out 6 and 3 to get the answer in the traditional approach, why even do it? Just use the values that are given to you. This is a mindset that I want you to take with you into the SAT. Can I just use the values? Can I do a shortcut based on the answer choices that have been given to me? So that's number 9, and I hope that helps.